Hello and welcome back to math class. Geometric sequences. Consider a sequence of numbers 2, 6, 18, 54. This sequence is clearly not arithmetic because when we subtract backwards 6 minus 2, we do not get the same thing as when we subtract backwards 18 minus 6. And that's the condition for arithmetic sequences. The significance of this is that there is no common difference. But what happens if we divide backwards instead of subtract? 6 divided by 2 equals 3. By the way, fractions are divisions. 18 divided by 6 is 3. And we keep getting the same thing. 54 divided by 18 is 3. So we can conclude that as a fraction is another word for a ratio, there is a common ratio because we always get this common fraction here. It's always 3. There's a common ratio between the terms of the sequence. And we label this as R. So we label the common ratio, we give it a name, we call this ratio R. It's 3. The implication here is that to get to the next term from a given term, multiply by R, because that's the opposite of dividing. Coming back, we divide, but moving forward, we multiply. So the next term is the current term times R. When there is a common ratio, the sequence is called geometric. Consider another geometric sequence of numbers: 4, -2, 1, -1/2, 1/4. Take any term and divide by the previous term, and you will get -1/2. This shows that the common ratio can be negative, and it can be a fraction as well. The general sequence is, well, the first term is still a, t sub 1 is a, and the next term is a multiplied by the common ratio. And the term after that is AR times R, which is AR squared. And the next term will be AR to the 3. And we can see that the exponent here is always one less than the exponent here. So if this is t sub n, this will be AR to the n minus 1. If this is n, t sub n, this is AR to the n minus 1. The general formula is t sub n is AR to the n minus 1. State the general formula and find the 12th term of the following sequence of numbers, which is geometric. Express the sequence using the general formula, so we know that a is 4. And when we divide backwards, let's just check and make sure we keep getting the same thing. -12 divided by 4 is -3. 36 divided by -12 is -3. And so we keep getting this -3, and so that would be our R value. So t sub n equals a times r to the n minus 1 was our general formula, and we just plug the numbers in. A is 4, R is -3 to the n minus 1. Please don't go 4 times -3 is 12. We cannot do that because of this exponent n minus 1. That's our general formula. And for the 12th term, well, we'll sub in 12 for n. And we'll get 11. And so it's 4 times, and then we need to figure out -3 to the 11th first, and then multiply by 4. Of course, a calculator will do that. State the general formula and the 12th term. Let's do it all again. Solution: express the sequence using the general formula. So dividing backwards, we see that the first term is 243, so a is 243, and then dividing backwards. R is a third because 81 over 243 is a third, 27 over 81 is a third, 9 over 27 is a third, 3 over 9 is a third. So R is a third. Our general formula for geometric sequence is A times R to the n minus 1. Plug in our known values, A and R, and please don't go 243 times a third here. It's very tempting. Don't do that, because it's not true. And that's our general formula, and we want the 12th term, so we'll plug in 12 for n. Minus 1 makes that 11. Now, 243 is 3 to the 5th, and a third to the 11th is 3 to the negative 11, or 3 to the negative 1 to the exponent 11. And now when we multiply powers of the same base, keep the base and add the exponents. So it'll be 5 plus negative 11, so the t sub 12 is 3 to the minus 6, which is 1 over 3 to the 6. Now 3 to the 6 is, well, it's 729. Not because of a calculator, but 3 to the 6 is 3 cubed squared. And 3 cubed is 27, and 27 squared is 3 to the 6. (27 squared is 729). Moving on, state the formula for the geometric sequence that has t sub 3 is 45 and t sub 7 is 3645. And you're given that it's geometric. You need to be given that. Sub the formula, sub into the formula twice and solve by elimination. There's our formula for geometric sequences, and here I am subbing into it. Now, this is a message. It's a coded message. It's saying that when n is 7, t sub n is 3645. When n is 7, t sub n is 3645. So we look at this and we say, okay, t sub n is 3645 when n is 7. Minus 1 is this 6. So this is where this comes from. It comes from this fact. Similarly here, this is a coded message. It's saying when n is 3, t sub n is 45. And so this will be the number 45 when n is 3. But 3 minus 1 is 2. Drawing a line and dividing, this is how we solve for two equations and two unknowns. When the unknowns are multiplied by each other, we divide. It's a new style of elimination. Perform the division here, 3645 over 45. Perform the division here, and the a's cancel. And r to the 6 divided by r to the 2 is r to the 4. When you divide powers of the same base, you keep the base and subtract the exponents. And we'll need the 4th root of 81. We'll take 4th root both sides here. So r to the 4th root, that's just r. And this is 4th root of 81. And that would be the number 3. Because 3 times 3 times 3 times 3 is 81. Now we'll take this r equals 3, and we'll plug it back up in here, just like in grade 10. It's called back substitution. So I'll put the 3 in there for r and figure out a. We have 3 squared, which is 9. And so it will be 9a equals 45, and divide by 9a equals 5. Now we know a, now we know r, and the question was, state the formula. Okay, the formula is t sub n is 5 times 3 to the n minus 1. And note, we're not going to go 5 times 3 is 15, as tempting as it is. Example, find the number of terms in the sequence. So there's this ... stands for some missing terms. And the question is, how many terms in the sequence? Using the formula. I suppose we could write them all out and count them, but let's use the formula. Solution. express the sequence using the general formula. Well, we know that a is 36. We know the formula is t sub n equals a times r to the n minus 1. So r is 18 over 36, which is the same as 9 over 18, which is 1/2. And this is our general formula. But this is t sub n. This is the nth term. So this 9 over 128 gets plugged right in here for t sub n. And for a, we'll plug in what a is, the first term, and for r, we'll plug in what r is, and that's 1/2, which we figured out up here. So we plugged it all into the general formula, and the question is how many terms? So we want to know n. We would like to know the n number. Now, it's critical that you don't go 36 times 1/2 is 18. You can't do that because of this exponent. However, you can divide by 36, and the 36 arrives here with the 128 as a factor. And this is the mechanism by which it does that. See, it arrives under there as a factor. Here's the mechanism. We're going to take this left side, 9 over 128, and divide it by 36. And that's the same as multiplying by 1 over 36, because when you divide by fractions, you invert and multiply. I used a dot to represent multiply. And here it is. Now it's top times top over bottom times bottom. So it's 9 over 128 times 36. That's the mechanism by which the 36 joins in there as a factor. Now I would just multiply it out, but wait, 9 over 36 can be reduced. So let's reduce it. It's just 1 over 4. So the 9 canceled and the 36 reduced to the number 4. And now on the bottom we have 1 over 128 is 2 to the 7, and 4 is 2 to the 2. And so this makes the left side 1/2 to the exponent 9. And why would I do that? Because now I've got the bases the same, and if the bases are the same, then the exponents have to be the same. So 9 has to equal n minus 1, and I know that n equals 10, and I can state that there are therefore 10 terms in this sequence.